Hello again and welcome to another GCSE Computer Science Theory lesson. This video is going to be on Unit 4, and for this lesson I'm going to do an optional little bit of history, so an optional history lesson for you. So why is this optional, and if it is optional, why am I doing this lesson? So it's optional because you're not going to be assessed about any of this stuff in the exam. It's not on the AQA specification. But the reason why I'm telling you about it is because I feel it helps students understand some of the content in Unit 4. And so in this video I'm going to talk about the history of a computer, and I'm going to tell you what a computer is, but perhaps more importantly what a computer is not. So let's start off with what a computer is not. So when people think of a computer, they think about something like Microsoft Windows or a MacBook, or error messages or viruses and things not working properly. This just straight up isn't what a computer is. This is just Microsoft's vision of what they feel an operating system should look like, but it is fundamentally not what a computer actually is. An example of what a real computer is something like the difference engine. So the difference engine was initially developed in the 1800s, but it never came to light, so it never went any further than a small prototype. But it's still an important concept in computer science because this was widely accredited as being one of the first documented computers. You'll notice that there's no screen or mouse or keyboard. It's because this was entirely mechanical. There was no electricity going through this device. You would input some information by turning gears and cogs, and the information would be the answer to whatever you had put in would be displayed on another set of gears and cogs. So it was all entirely mechanical. Fast forward to the 1900s, you had things called adding machines, and these were really old-fashioned calculators. So they were calculators that didn't use electricity. So instead of using digital buttons and an LCD display, again they used a series of cogs as inputs and a series of cogs as outputs. And you would just turn this little crank here and it would eventually compute your answer, but completely electricity free. It was entirely mechanical. Fast forward to the 1940s, you have something known as the bomb machine, which is widely accredited as being one of the first electronic computers. So this computer used a series of ons and offs, ones and zeros, so binary data to compute answers to problems. And in this scenario, the bomb machine was used to break codes in World War II, so to try and decipher the codes that Nazi Germany was using to communicate. This eventually led to Allied victory. Some interesting trivia for you. One of the key players in developing this machine, Alan Turing, despite the fact that he helped British victory, was actually prosecuted by the British government just for being gay, which is a pretty horrible thing to convict somebody of. It shouldn't have even been a crime. So what a horrible thing that happened to Alan Turing. He helps out his country, and then his own country prosecutes him and arrests him, and which eventually led to him killing himself. Anyway, moving on. Go forward to the 80s and you started having pocket calculators, and these used electricity. They used a series of ons and offs. They used binary data. They had little processors in them to try and calculate answers. So these are very much modern day computers. Fast forward to the 90s and you start getting CPUs in the style of what you see today. So something to be aware of is that the processors that you have in your laptop or the PC that you're using to watch this video, they haven't changed very much since the 90s. They've certainly gotten faster, but the design and the architecture has pretty much stayed the same. So why am I boring you to death with this history lesson? What is the point of it? Well, I want to really try and hit home what a computer actually is. And a computer is just a magic box that takes some inputs and converts them into outputs. So in the example of the difference engine or a calculator or an adding machine, you would input something like 4 plus 4 and it would output the answer 8. With a more complex example like a modern day computer, you would input something like, well, you'd be inputting things on your keyboard. So you'd use your keyboard. You'd use your keyboard and you would use it to input messages like hello, and potentially you could output the word hello on your screen. Or you could print out hello in a Word document. Or you could output some text into a Word document, and then eventually this would come out of your printer. So a modern day computer is still, in terms of inputs and outputs, it's just a little bit more complicated.